Hello everyone, welcome to my new video in my Mathematics Essentials series. In this video, I'll continue proving trigonometric identities and prove identities 6 and 7. Okay, now in order to prove these, we will make use of identities 8 and 9, which we have already proven. Identities 8 and 9 are sometimes called the coangle identities, and we will also make use of identities 1 and 2, which we have already proved, that sine is an odd function and cosine is an even function. And I like to think of them as the parity identities because they describe the parity of those functions. Okay, so let's start the proof, or let's write out what we are going to prove. We will prove trigonometric identity 6 first. Okay, so trigonometric identity 6 is that the cosine of pi over 2 minus theta is equal to the sine of theta. Okay, that's what it says. We're proving this one. Okay, now let's start the proof. In order to do this, we will write the cosine of pi over 2 minus theta equals, okay, we will express this difference of angles as a sum of angles. Okay, the cosine of pi over 2 plus some other angle, which happens to be negative theta. And now that we have written the argument of cosine as a sum of angles, we're justified in applying the coangle formula. Okay, now the coangle formula that we will apply is this one here. Okay, trigonometric identity number 8. It says the cosine of pi over 2 plus some other angle is equal to negative sine of that angle. Okay, so let's write that. Okay, this must equal negative sine of that angle, all right, which happens to be negative theta. Okay, but you know from trigonometric identity 1 that sine is an odd function. What this means is that whenever the argument of sine is negative 1 times some angle, you can just take the sine of that angle being positive and pull the negative sign out the front. So what this is really negative sine of positive theta. Okay, so we could put that in brackets to say that it's negative 1 times negative sine of positive theta, but of course negative 1 times something negative makes that thing positive, so we just have the sine of positive theta, and that's what the identity says. So that completes the proof. Now let's do the other proof. Okay, so now we are proving trigonometric identity number 7. Okay, so it says that if we take the sine of pi over 2 minus some angle theta, well, that's equal to taking the cosine of positive theta. Okay, now the proof will be similar. We will just apply the other coangle formula for sine. Okay, so we can write this difference of angles here in the argument of the sine function. We can express it as the sum of two angles. Okay, pi over 2 plus some other angle, which happens to be negative. All right, then we apply this coangle formula for sine, which says that the sine of pi over 2 plus some angle is just the cosine of that angle. Okay, so that would mean that this is just equal to the cosine. Sorry, I think I said something wrong. Whatever I said, I meant to say that the sine of pi over 2 plus some angle is just the cosine of that angle. I hope I said that. In any case, that's what I mean to say. Okay, so this is just the cosine of that angle there. All right, so this is the cosine of negative theta. All right, but we know by trigonometric identity 2 that cosine is an even function. What that means is that when we take the cosine of some negative angle, it's the same as taking the cosine of positive that angle. Okay, and this is just what the identity says. So that completes the proof of this identity. Okay, so let's go back up to our list and cross off the two identities we've proven. So we have proven trigonometric identities 6 and 7. Okay, so now we've proven 13 identities in total of our list of 19, so that just leaves 6 identities to go. All right, if you enjoyed this video, feel free to give it a like. If you have any questions about what we've done, just leave those questions in the comments, and if you would like a notification whenever I upload a new video, just subscribe to my channel. Until next time, bye for now.